Okay, cool. So hello everybody. Now I want to get a couple of things set from the start. This is a 101 session, absolute basics. If what you're looking for is an advanced, I've done the beginnings, I want something really unique and advanced, then this is not the session for you. If that was what you wanted, sorry, send me a message on Twitter. You've got my Twitter handle right there, and I can probably recommend some alternative content that might be more appropriate for you. This is a 101 class. And when I say 101, what I mean is I'm going to talk about the key concepts behind DevOps. One of the problems that people jump to is they immediately start jumping to tools. They immediately start talking about deployment pipelines or infrastructure as code. But what I really want to do is peel back the layers on that and talk about why it is we do this stuff. And I'm going to start by telling a story. You'll come to a place where the streets are not marked. Some windows are lighted, but mostly they're dark. A place you could sprain both your elbow and shin. Do you dare stay out? Do you dare go in? How much can you lose? How much can you win? And if you go in, should you turn left or right and 3/4, or maybe not quite? Or go around back and sneak in from behind? Simple it's not, I'm afraid you will find, for a mind maker upper to make up his mind. You can get so confused that you start into a race down long, wiggled roads at a breaknecking pace and grind on for miles across weirdish, wild space, headed, I fear, towards the most useless place, the waiting place, for people just waiting. Waiting for a train to go, or a bus to come, or a plane to go, or the mail to come, or the rain to go, or the phone to ring, or the snow to snow, or waiting around for a yes or a no, or waiting for their hair to grow. Everyone is just waiting. Waiting for the fish to bite, or waiting for the wind to fly a kite, or waiting around for Friday night, or waiting perhaps for their Uncle Jake, or a pot to boil, or a better break, or a string of pearls, or a pair of pants, or a wig of curls, or another chance. Everyone is just waiting. It might be obvious that I became a parent in the last year, and I've been reading that book a lot to my son. But I only recognized the relevance of that when I was reading this book at the same time for myself. And Gene Kim in the Unicorn Project literally quotes that passage that you see on the screen as what it felt like to work daily in an IT organization at the moment. We're waiting. We're always waiting. I want to do something, I'm waiting. I'm waiting for an environment to be provisioned for myself. I'm waiting for somebody to approve my changes. I'm waiting for somebody to triage my changes into a deployment. I'm waiting for the authority or the sign off or the buy-in or blah, 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 blah. How do we get anything done? Who has the ability to actually do something and see it to completion in one go without waiting for 150 people to get in the way? Now, of course, there are very, very good reasons why we need to wait for other people, because we're in a team. There are very, very good reasons why it's appropriate to put a certain amount of due diligence into the releases that we're shipping out to millions of people, absolutely. But we're doing it in the wrong way, because we're doing it in a way that's meaning that we are thoroughly, thoroughly unproductive and inefficient and unreliable at releasing software. And DevOps is about trying to fix that. Now, how we do it, so many ideas, so many things. I'm not going to talk through all of these different ideas. The reason I'm putting this slide up is just to show you how overwhelming it is. You've probably seen some of these ideas. You probably understand what some of them mean. You might not know what all of them mean. You might not know the relevance of pizza, for example, to software development. But there's this huge stack of tribal knowledge that people are carrying around, and this huge stack of ideas that we need to be source controlling our stuff or deploying our stuff or using a chaos monkey, whatever that is. There's all of this stuff that's come along, and the people who are doing DevOps wrong are just copying the ideas. And I could have come here and done a presentation where I showed you a deployment pipeline and said, this is how you automate your deployment or so on. But if you're just copying the ideas, you're missing the point. So I'm going to try and take a leaf out of Simon Sinek's book, Start With Why. He makes a point that people don't buy what you do, they buy why you do it. People didn't turn up, as he in his own example, for Martin Luther King because he had a plan. They turned up because he had a dream. And It's the idea, it's the principle, it's a guiding philosophy behind these things that implement the things that we do. And for the people who just focus on what we're doing and missing the entire point. So in this session, I'm going to start by talking about why. Why is DevOps important? Why is it, what is the overall goal? What are the problems that we're trying to solve? Then I'm going to talk about how. So what are the principles? What are the things that we need to do in order to deliver on our why? And finally, what does that look like? And that's where I'm going to give you a demo. So there will be some code. I promise we'll get to some code, and I promise we'll get to a demonstration, and you'll be able to look at it on your machines, and you'll be able to see everything that I'm doing. You'll be able to download it and try it for yourself. Absolutely, you will. But we've got some homework to do before we get there. So why? Why should everybody care about DevOps? And I don't care what your role is. I don't care what it is. Why should everybody care about it? This slide was presented by Andrew Clay Schaefer at Velocity Conference. Now, Velocity Conference in 2009 in California has gone down in history for a talk called 10 plus deploys a day at Flickr. And John Allsport and Paul Hammond kind of got the world's attention with this idea of these warring silos of development and operations. But the single best slide at that conference that really demonstrates this warring faction siloed nature of the development of how inefficient we are at working with IT was actually created by Andrew Clay Schaefer in a different session that was unrecorded. So unfortunately, we can't go back and watch it. He talks about the wall of confusion. And later we've come to call this the core chronic conflict. The core chronic conflict between development and operations. Developers, if you have an organization if you have an organization, I'm going to turn off Slack because I've just seen notifications in Slack that made me laugh. Sorry, Anthony and Andrew, go away. In an organization where you organize your teams, you have a development team over here and you have an operations team over here or a DBA team. It's become a joke nowadays that these teams don't tend to get on. They tend to be always fighting and conflicting. And that's because developers have certain goals. They need to respond to urgent business needs. They need to get the work out of production. They want to do stuff. They want to make changes. Whereas at the same time, operations folks, DBAs, sysadmins alike, they care about secure, reliable, stable IT. If everything goes down, it's them that gets the pager alert at 3 a.m. and is still expected to be in the office at 9 o'clock. And well, maybe not polite. They tend to be quite grumpy, but they've got to be there doing their job. Now, any change to a system has some inherent level of risk, any change, and we're never going to be able to get that to zero. And any efforts to try and get the risk of a change to zero are a waste of time. We're never going to get to zero, which means that whatever we're doing, there's always going to be an element of risk, which gets to the core chronic conflict. The developers want to make it as quickly as possible. The operations folks don't trust the developers because they've got a history of breaking stuff, and they want to protect their system because they don't want to get woken up first thing in the morning. And this core chronic conflict creates businesses that are at functional war with each other, huge bureaucratic processes. The amount of time it takes to get to production gets longer and longer and longer. Our deployments get bigger and bigger and bigger and more complicated, and they would go wrong more often. And it just spirals this distrust and this inefficiency and this inability to get anything done. It's a vicious circle. Now, lots of books have been written over the years about this, and this is just an example. This is a picture of my bookcase back there, and actually some of those books are now here, and I'm going to reference them as we go. And what I'm going to try and do in this talk is to bring out some of the most important concepts from this stuff, some of the most important ideas, and I'm very much going to stand on the shoulder of giants. I'm not a thought leader, whatever that means. I'm not an expert. I'm not the person that's going to come up with a new fantastic way of optimizing your deployments. What I try and do is I try and share the ideas of others. I'm standing on the shoulders of giants. So what I'm going to do in this talk is barely any of it is my content. I'm all just trying to highlight this person said this and this person said this, and this is how it all links together, and this is why it's so important. So there's been a whole bunch of great books. There have also been a whole bunch of surveys and polls and things, and a whole bunch of research has been done in this space. You may have come across the State of DevOps reports. They're probably the most widely known and most well understood, most famous poll that's going on. What they do is they poll hundreds of thousands of IT professionals around the world. They ask them a whole bunch of questions, they bring that data back, and then they do some research based on it. And the best place to start, I think, your journey, if you want to understand what it said, is the book Accelerate by Nicole Forsgren, who has actually just been hired by GitHub or Microsoft, or I'm not entirely sure I understand the relationship there, but she's going to go and join GitHub. And she used to work at Google and various other different places. And in Accelerate, one of the key, most important things that they did is they've highlighted these 4 key metrics. These 4 key metrics that predict IT performance based on the research from the State of DevOps: deployment frequency, lead time, mean time to restore, and change failure percentage. And the key thing about these is they don't just predict IT performance or define IT performance to a certain extent. Analysis over several years shows that high-performing organizations were consistently twice as likely to exceed the profitability, market share, and productivity of low performance. This isn't just about theory. This is about business practice. This is about the companies that are winning in the marketplace and making money. This is about the people who are really changing the world of IT. And if you want to be in that group, you need to learn to understand the ways that those sorts of organizations think about software. Let's come back to those 4 key metrics, because there's one consistent thing that is key to all of these metrics. In order to achieve any of these things, you need to think about, your batch sizes. You can't deploy frequently if all of your deployments are massive. They have to be small, easy to deploy things. You can't deploy quickly if you're trying to batch 12 months worth of work into one big release. You need to release a small thing at a time, focus on one thing at a time, get it off the backlog, get it into production, and then pick up the next thing. Don't let that thing sit for hours and hours and hours in the test environment, and don't let things hold you, don't let approvals or environment provisioning slow you down along the way. When we think about mean time to restore, this changes the mentality of how we think about risk. Ultimately, as a user, I don't care about the particular risk of any particular one release. What I care about is how often is your service online? How often is it offline? And when it's offline, how long is it offline for? What I care about is the availability of your service. So focusing on the reliability of a particular release misses the point. What's far more important is, if it goes wrong, can you recover from it? How long is it going to take to recover from it? And how many of your deployments go wrong? So it's not about chasing absolute zero risk. It's about constantly trying to minimize the risk without reducing batch sizes. So we're deliberately aiming for a high frequency of deployment. And it's about ensuring that we can recover from deployments quickly. These are the 4 key metrics that define whether or not we're going to be successful at IT, and effectively whether we're going to be successful with the work that we're doing. As Chuck Rossi puts it from Facebook, if we make more changes, we need more deployments. He's basically clarifying that you cannot scale up deployments, you have to scale them out. And the reason he came to that conclusion is that he observed at Facebook that once a release reaches a certain size, once it has a certain number of changes, once it reaches a certain level of complexity, it never, ever, ever goes successfully. So if you want to do more stuff as an organization, if you want to grow, you cannot do that by making your releases bigger. You have to do it by releasing them more frequently. The limit to how much stuff you can get done and how much value you can add is not how big your deployments are, it's how many of them you have, which is why there's this constant focus of moving from a quarterly release cycle to a monthly release cycle to a weekly to a daily to an hourly we want to get that as short as possible. Which brings us back to these 4 key metrics. So if anything, DevOps is about hitting these targets. If we think about coming back to our core chronic conflict, what that's going to do, if we're really moving to a process where we're releasing significantly smaller changes, they are less risky because there's a lot less that's changing. So they're less likely to go wrong. they're also going to be easier to recover from if they do go wrong. It's a lot easier to understand what went wrong. If you're trying to release a year's worth of development with 150 different applications all at one time, and one application over here starts interfering badly with an application over here, suddenly I've got a really complicated problem, and trying to roll the whole thing back might be quite difficult, especially if I'm working with databases and data, because of the persistency problem. So it becomes even more important to move to a more frequent, smaller release cycle. That makes our releases a lot safer, which means our operations folks are more likely to trust our development folks, which means that now we have safer releases, we feel more confident doing it more frequently. And as we do it more frequently, it gets safer. And as it gets safer, it turns that vicious cycle into a virtuous cycle. And it's fun. That's the fundamental engine that is the difference between the high-performing Netflixes and Amazons and Googles and of the world and the organizations that aren't doing that. So this is what we want to do. We want to move to smaller releases more frequently, and we want to be better at recovering from them when they go wrong. And we want to make sure that as the biggest percentage of possible of them works. How do we do that? Because if we all think to the organizations that we work in at the moment, whether we're experienced in our careers or whether we're just starting out, we'll probably recognize that we're not releasing on an hourly basis yet. Most of us aren't, unless you're working directly on production, which has all of its own problems. The way that we get there is through DevOps, but DevOps itself has two main schools of thought which have influenced it. One of those schools of thought is lean, and the other school of thought is safety culture. And what I'm going to do now, I'm going to try my best in the time that I have to give you a brief overview of what I mean by lean and to give you a brief overview of what I mean by safety culture, because these are two massively loaded terms. But I mean, that's not just a session in its own right. Each of those is a conference in their own right. So I'm going to do the best job that I can of trying to explain a massively loaded concept in a few short slides. And I apologize to all the people who understand these concepts in a huge amount of detail, because I'm going to be oversimplifying them. The picture behind is Eliyahu Goldratt, who is a guy that wrote this book, The Goal. It's the story about a manufacturing plant that is not performing very well. They have impossible looking deadlines. They have an impossible looking cash flow situation, and they've basically been told they're about to close the company unless they can turn around their fortunes, but they're constantly firefighting because everything is always going wrong. They spend more time fighting fires than they do actually solving problems. And while it's based in a manufacturing facility that creates parts for cars, the similarities with how most of us feel in our day-to-day work in software are remarkably striking. And what he said is that in any flow of work, there's a direction of flow, but there is one and only one bottleneck, and any improvement not made at the bottleneck is an illusion. So let's think of this in terms of the work that we're doing. Let's imagine that we have some sort of backlog of tasks that some product manager has asked us to achieve, and we have our production system, and that's where we want to put all the work. And I'm not sure whether I've been reversed or not, so I don't know whether I'm going right to left or left to right, but bear with me. To get something off the backlog into production, I need to do some development work. I need to do some testing. I need to check that code into source control. I need to deploy it somewhere. There are all sorts of things that need to happen between getting it into production and not. And if there is a bottleneck, there will always be one part of that system that is the thing that defines the pace that the entire system runs at. Whatever is a part of the system that has the least capacity is a thing that ultimately will define how quickly you can release work. Now, whether that be the person that needs to approve the deployments, whether it be the development effort, whether it be the testing effort, whether it be the deployment process itself, there'll always be exactly one element in that pipeline that is the ultimate bottleneck of how quickly you can get into production. And lean is basically the concept of understanding where that bottleneck is, making sure that that bottleneck is working at optimal capacity and that everything else in the pipeline is subservient to that bottleneck. There's no point in anybody working any faster than the bottleneck. because the moment they've got any spare capacity, they should be working on alleviating the bottleneck and thinking about changing the ways that we work to avoid that bottleneck entirely, because that's the thing that makes us much, much more effective. There's no sense telling everybody to work harder. There's no sense telling everybody to work more hours a day. There's no sense saying, right, developer, you finish that piece of work, pick another one off the backlog, because all you're doing is creating problems for yourself downstream. Because wherever that constraint is, it's got more work than they can possibly do, and then they just resort to frantically going from this task to that task and doing whatever the person that shouts loudest asks for, rather than actually what's the most important thing. So first thing, one of the primary tools that lean thinking recommends is coming up with a value stream map. So it's drawing out all of the things that need to be done for a piece of work, and understanding how much time is spent on them and how much time is spent waiting. And the picture you're seeing right now is a photo I took from my personal copy of the DevOps Handbook, which you can see has got all my notes and things inside it. And this is fairly typical. And the alarming thing is, when you actually add up all of the things that were done and the amount of time between picking up the ticket from the backlog and deploying it to production, let's say that took 2 months. Let's say it took 2 months to actually get something into production. The actual amount of time that anybody was spent working on it was minimal. In this case, which is a fairly typical case, it's 8.6%. This value stream was single-digit percentage efficient. And actually, whenever I go into an organization, and this is one of the first things we'll do, we'll look at, right, what are all the things that we need to do to get code into production, to get work done? The vast majority of the time, we're in single digits, and we're in low single digits of percentage efficiency. A lot of tickets might take an hour or two worth of dev work, but then they need to wait a week for somebody to approve them. And what's the consequence of that? Well, it's one of two things. Either there's just a huge amount of waste and people aren't being efficient, which is probably true, or we're probably waiting on deployments. We're probably batching things up into big deployments, which means that our deployments have probably got 150 little features in them, any one of which could go wrong. And then when it gets deployed, trying to get all the different people that were responsible for that piece of work in the room to and trying to understand what's gone wrong, it just becomes impossible to manage. And this is where we end up having many, many layers of bureaucracy and management that don't really add very much. What would be far, far more effective is if we can significantly increase our efficiency, and we can get stuff into production much, much more quickly in smaller batches, a single thing at a time. We can then, when the business asks us, hey, can I have this feature? We can say, yeah, we can get it to you this week, because we know we can. We're not going to say, oh, we'll put it onto the backlog for 6 months in the future. No, if it needs to be done, we can get it done. And if it doesn't need to be done, we can say, well, I'm sorry, it's not as important as this piece of work. And the businesses tend to like it when we work in this way, because it means that we can actually confidently deliver stuff on time for them. And our deployments are going to be significantly more likely to succeed. To summarize, so that's a very quick overview of some of the bits of Lean, but I've got a few other things to think about here. So Lean is much broader than just that. So one of the easiest ways to break it down is from Lean Thinking by Womack and Jones. They break Lean down into 5 key concepts. Value. Understand what is the point in the work that you're doing, what is the most important thing. And this necessitates, for example, a relentless focus on, hello, Stu. This necessitates a relentless focus on your end users, what they actually want, what's useful, what's valuable, what's the most important piece of work that you can do right now. Understanding the value stream. So that's what I was just talking about, getting stuff into production nice and quickly. Flow. So that's making sure that we're working in an optimal way and developers aren't constantly distracted with distractions and so on, which we all know are horrendously inefficient. Pull. Now, this is related to value streams. It's more important to finish work than it is to start work. Because if we're starting work while stuff is still sitting in our deployment pipeline unfinished, then all we're doing is we're loading a huge amount of work in progress into our system, and we're creating problems at the bottleneck, and we're not going to be doing a good job for lead time. As I mentioned, it's far more important to focus on relieving the constraint than just piling up huge amounts of work in front of it. And Kaizen, which is a concept of continuous improvement and always wanting to improve our system. DevOps isn't an end point. DevOps is a state of being where we're always looking to try and improve on what we're doing. Another way of thinking about the consequences of DevOps, Mary and Tom Poppendick, and this isn't a new book, this is from like 2003, the 7 Deadly Sins of Software Development. And what they've done is they've taken 7 key problems that are recognized by lean manufacturing, and they've turned those into very real things that software developers can understand. So inventory is the amount of stock that's piling up in your warehouses because it's piled up in front of a constraint. What we're talking about now is partially done work. So that's where Kanban boards come into play. That's where ticket tracking and the management of work through our system, understanding where is there a huge pile of unfinished work, why is it there, what bottleneck is it stuck in front of, because that points at particular problem areas in your process that could do with automation or whatever else. Overproduction, feature creep. Overproduction is where a product manager says, I want all of these features and I want them done tomorrow, when actually the likelihood is it's only 1 or 2 of them that are actually going to make a measurable difference. So understanding what those most important things are and focusing on what's important. Extra processing, relearning. This is where you make a mistake and then you make the same mistake again, and the next person that comes along makes that mistake, and we're inefficient, and we can't, as an organization, learn to practice and embody the best practices. That's where automation and source control and scripting comes into play. Because rather than doing something manually and relying on somebody's personal knowledge in their mind to do something, we write a script for it that we can track. It's fundamentally more efficient, and we can track who changes it, what, and when, and why. And we can understand, and we can constantly try and improve it rather than just always doing it the way we've always done it because we're afraid of changing it, because we don't all understand how everything works. Transportation, this is in a manufacturing sense, it's about moving stuff around in lorries. We're talking now about handoffs. So each point in your process that relies on somebody else to approve something or deploy something, or where you're passing, throwing some code over the wall of confusion from development to testing to operations, each time you do that, you lose something like 50% of the knowledge and understanding of what's actually trying to be done. And it just becomes a button clicking exercise. And that's where DBAs end up being F5 monkeys and hitting deployments. And that's not good for the DBA, because the DBA's got better things to do and doesn't like being an F5 monkey. It's not good for the developer because it just creates delays. So we want to be able to put the authority and autonomy in the people that write the code to be able to take ownership of the deployment pipeline. Motion, that's context switching. So in a manufacturing sense, we're talking about switching the configuration of a machine to work this way or that way. In software development terms, we're talking about context switching. If you are in the flow of development, you're writing some piece of work, you're 15 levels deep in a complicated problem, and somebody taps you on the shoulder and says, hey, can you just do this urgent task for me? It's likely that your productivity is shot for the rest of the day, and anybody that writes code understands that. And it's exactly the same thing as you see in a manufacturing plant, where you need to disruptively change the configuration of a machine that was pumping out doohickeys. It's exactly the same thing, except it's visible in a manufacturing plant and it's invisible in a software plant. So it's all about understanding that problem, making it visible so that we can see that actually, in order for our people to be effective, we need to give them the space and the freedom to focus on the task at hand rather than constantly interrupting them. And defects, obviously, when we screw stuff up, that's a problem. And when we do that, we want to be aware that we screwed it up as quickly as we possibly can be, so that we can fix it and rectify it as quickly as possible. And also, it's really important to understand when we screw stuff up quickly, because at that point, we probably still understand what we were doing, and we can see the link between cause and effect. If it takes us 3 months to get the feedback from the testing department that there's a problem with my code, well, now I've got to go back and think about code I forgot about because I wrote it 3 months ago. That's highly inefficient. Whereas if my CI server spots that I've made a mistake 30 seconds after I've committed it to source control, it's likely that I can still remember exactly what I was doing, and I can fix it much, much more quickly and more efficiently. So that's all I'm going to say about lean for the time being. I tried to get through it as quickly as possible and summarize some really big, beefy concepts in as quick as I could without doing a massive disservice to them. I'm going to do an even quicker job of safety culture, which is awful, but I'm trying to discuss so much in one session. So safety culture also doesn't come out of IT. Where lean software development comes from kind of the car manufacturing industry, safety culture comes from the healthcare system, the aeronautical system, areas where safety is absolutely critical. The picture that you can see, or that's kind of faded out in the background, is the Chernobyl nuclear power plant in Ukraine. Ukraine, Belarus, I forget, one of the ex-Soviet states. Oh, that's awful. Somebody will say in the chat window where it was. And one of the things that they recognized there was no single root cause. Chernobyl happened for a variety of reasons. There was mismanagement from the top. There are poorly trained staff carrying out actions, and the architecture, the engineering of the reactors itself was problematic. There was no one particular thing that you could point at. If the reactor cores had the problems that they had, but it was managed properly and the people were trained, Chernobyl would never have happened. If we had poor management from senior leaders, but the reactors were built properly and the people who were doing the work knew how they worked, Chernobyl would never have happened. If we had poorly trained people who were running the system, but senior management understood everything that was happening and it was architected to protect itself from mistakes from frontline engineers, to be a fundamentally safer system to manage, like most modern nuclear reactors are, Chernobyl would never have happened. It took the simultaneous failure of all three things for Chernobyl to happen. In complex systems, systems fail in many different ways, and there are 18 points that were raised by Richard Cook, who was actually from a healthcare background, to understand, look, in any complicated system, whether it be a hospital and everything that goes on in a hospital, from doctors to supply chains to operating theaters to patients with unusual and conflicting issues, whether it be aeronautical, whether it be flights, whether it be the relationship between the pilot and air traffic control and the design of the plane and the corporate mechanics, whether it be the Apollo missions, in any complex system, things don't fail for a single root cause. There are all sorts of complicated reasons why they fail. And what Richard Cook did is he listed out 18 key characteristics. And one of the key important ones is psychological safety. Now, we talk in IT about blameless postmortems. We talk about if something goes wrong, everybody needs to be able to be free to talk freely without the fear that they're going to get fired about what went wrong, and to freely admit, okay, I did this thing here and it was the wrong thing in that scenario and maybe I should have done this thing instead. And we struggle with that in the context of software development. Imagine being responsible for an operation that went wrong where somebody died. Imagine being responsible for the design of an aeroplane that crashed and killed hundreds of people. And then imagine having that conversation about, oh yeah, I screwed up. When we complain about bureaucracy in IT, we have to come at it from a position of understanding that, look, for the vast majority of us, we have it far, far easier than other industries. So it should be far easier for us to be able to create that safe culture where people can talk and analyze and discuss what went wrong and talk freely about the steps that could or should have been taken differently and how we can improve on that. There's a huge bunch more great stuff that comes out of safety culture that is directly relevant to what we do in IT. So I encourage you to Google safety culture or safety 2.0 or how complex systems fail. Because there's a huge amount of great stuff that is hugely relevant to IT, despite the fact it wasn't written for IT in the first place. We're all, I'm sure, familiar with disasters where a change has been made to a system over here, and we weren't aware of various different dependencies on things that ended up in something failing over here with disastrous consequences. So we take from safety culture and we take from lean, and we understand that these are both brilliant concepts and ideas and schools of thoughts that we think are directly applicable to software development. And then we have the challenge of, okay, what do I do about it? Because there are so many big and complicated ideas that I've talked about, and this is why DevOps is so hard to define. You can't just define it in a word. It's a recognition of these huge concepts and ideas and how we embody them and how we implement the changes. John Willis had one of the first goes at attempting this. Actually, he initially came up with CAMS. It was Jez Humble who wrote Continuous Delivery, which is on my bookshelf, with Dave Farley, that added lean later. You say we start with culture. We need to create an organization with psychological safety where we can talk freely and we can all do the right thing without having to deal with warring factions or blaming or scapegoating. We need to embrace automation because we need to be able to build on the things that we all do. If we've done something, we should be writing a script for it and saving it in source control so that we can iterate on it and improve on it rather than letting that knowledge live in our heads. And also, by the way, we literally invented computers to do boring, repetitive tasks. So let's let computers do that rather than making humans do it. Lean, we've talked about measurements and sharing. If we can't see what's going on, if we can't understand it, we can't possibly make great decisions about it. So we need to make our feature usage reportage. We need to make our CI data. We need to make our performance telemetry. We need to make that available and usable by all the people involved in writing software so that we can effectively prioritize and decide what the most important work is, what is the most valuable thing that I can do. And that all sounds great, but how do we get there? So one of the next things that came along was Gene Kim with the Phoenix Project, which is this book. If you haven't read it, definitely read it. It is a novel about every software team you've ever worked for. It's a satire, you will read it, you will recognize yourself, you'll recognize your colleagues, you'll laugh, and then you'll cry because it tells the story of where you work. And it also helps to articulate some of these ideas. And one of the ideas it articulates is the 3 ways flow. The first thing we need to start thinking about is value stream mapping, the focus of getting stuff from our backlog into production as quickly, efficiently, and safely as we possibly can. And when we're doing this, we need to optimize for the whole rather than any individual department. And if we have a clear vision and view about that, it helps us to avoid organizational fighting. The next thing we need to do, and one other way that was expressed in the early days, is aha to ka-ching. The goal of DevOps is to go from great business idea to running in production as quickly as possible. And the organizations that can do that win. The next step is feedback. Once we know that we're good at putting stuff reliably and safely into production, we then need to think about feedback. We need to think about, okay, did it work? Did it meet my business objectives? You told me to make the button green rather than blue. Great. Do people understand it better now? Are people using it better and more people paying us money? If you can't create that link, if you don't understand that link between the work that you're doing and the value you're creating, you need to ask some questions about why. Why am I doing this? Why is this the most important thing I'm doing? And also, when I've done it, did it work? Could it be better? Could I iterate on it? And it's the people that take that scientific plan, do, act, measure approach that are the people that create the amazing systems that are changing the way that we use IT. And it's the people that don't do that that are failing. So this is the process we need to go through. We need to focus on lean principles to get stuff into production as quickly and efficiently as we can, value stream mapping, and that involves deployment automation and finding our bottlenecks and all the rest of it. We need to think about feedback, making sure we're aware, we understand, we can learn, we can grow, and then and that will build this creature of continual experimentation and learning, which promotes innovation, and not just innovation, but also the ability to deliver on it. In the follow-up to the Phoenix project, the Unicorn project that was released last year and is also a good read and has the reference back to Oh, the Places You'll Go by Dr. Seuss. Gene Kim tries to simplify it down to, right, what matters to a developer? What are the things that we should care about? What does good look like? And he gave us these 5 ideals: locality and simplicity. I want a developer, or whatever their role is throughout the pipeline, to be able to work locally, simply in a small setting, and I want it for them to be easy to do their work without having dependencies across 15 different business units across the organization. I want people to be able to work with focus, flow, and joy. I want them to be able to concentrate on the problem that they're solving without interruptions, and I want them to be able to see the benefit of the work that they do. There is nothing that gives you satisfaction in work like seeing the fruits of your labor. So we need to be able to see, I've done my work, I've seen it deployed to production, and I can see that it's delivering value. I can see that it's making people happy. People get into software development because they want to create great software. If you don't get to see the result of the work that you're doing and get to see the delight in your users, then it's very easy to burn out and get disenfranchised very quickly. And by the way, this has a very significant business benefit because it improves your retention rates, and it means that you create teams with much deeper knowledge and understanding about their product who are much better able to deliver on it. So they're very, while that feels like a touchy-feely individual goal, actually there's a very clear business incentive for that too. The improvement of daily work. We should recognize that in Gene Kim's words, improvement in daily work is more important than work itself. We need to create this culture of psychological safety and customer focus. Again, I've spoken about these things a few times. So hopefully that gives you an idea of why DevOps, what it is DevOps is attempting to achieve, or how it's planning to go about it. And now finally, in the last 5 or 10 minutes of this presentation, I'm actually going to start talking about some practical technical things that we can do to help. So Accelerate recognized 24 key capabilities that drive improvement. I'm not going to read through all of these, but I'm going to pick out a few that are obvious. And this is improvement with respect to the 4 key capabilities that we mentioned before. Version control, deployment automation, test automation, continuous delivery. These are some of the very first things that we need to think about. To try and simplify that big slide with lots and lots of things on it, Gene Kim makes it a bit easier for us. He says, what I find, and he says this in Beyond the Phoenix project, which is an audio book, and it's great, and I've listened to it many times. What I find so amazing is that as an organization goes from code deployment lead times that are measured in months, maybe in quarters, down to minutes, the constraint moves in some pretty predictable ways. Environment creation, and the solution to that is infrastructure as code. Code deployment, and that's continuous delivery. Testing, so now we're looking at shift left and automate your testing, or test automation. Architecture, and this is where we start talking about loosely coupled systems and potentially microservices if you want to start that flame war where small changes create small problems, local problems, as opposed to small changes creating global disasters. We want to create an architecture for our system where teams can work autonomously on their piece of the puzzle in the understanding that if they break something, they've only broken their bit, so that you don't need 15 layers of approval to get anything done. And then finally, we end up with ideas or innovation. And that's where it should lie, because actually the point is being able to get our idea into production. And at the point that our ability to think of the next thing is our bottleneck, that's when we can start performing, because that means that the IT department isn't the bottleneck anymore. It's not our ability to deliver software that's a bottleneck. It's we can begin to start thinking about, right, what should we build? What's the most important thing? And they're the most exciting organizations to work in, because suddenly we're talking about solving problems rather than cutting code. So now I'm going to give you a demo because everybody wants to see a demo. This is where my demo is. Also, by the way, if you go to this location, you will see my my slides. So this is github.com/alex-yates/DevOps101_demo. If you go to the slides, you'll see my slide deck there. For anybody, I know that's going to be an inevitable question, where are the slides? What I'm going to do is, so this is my public GitHub repo. Source control repo is basically a place where I can keep code. Again, I said this is 101, so I'm going to try and explain this at a basic level. It keeps track of all the changes I've made to my code. So for example, when I made this change, here was the change I made to the code. I'm not going to worry too much about that right now. What I want to do is I want to get that code onto my machine. The most important thing is environment creation. And you've just seen a presentation from Andrew Prusky all about containers. They are great. They're one tool that make it a lot easier for me to provision myself an environment without having to jump through layers of approval. I'm not going to play with containers now because I want to try and keep my demo simple. So I'm going to clone this repo down to my local machine. So I'm going to copy that URL. I want to pull the code onto my local machine. Remember, locality and simplicity. So I'm going to just tap PowerShell in here. That's going to open a PowerShell window to the appropriate location. Bet you didn't know you could do that. Little productivity hack for you. I'm going to write git clone, and I'm going to paste the URL that I just copied from the website, and that's going to pull all the code down locally. That is all that you need to do on your machines to pull down all of my code and all of my slides. You'll see now that in that location, I have the Git repo. And in here, if I go into AdventureWorks, you'll see I've got this solution file. I can click that. It's going to open it up for me in Visual Studio 2019. I now need to wait while Visual Studio runs. This is going to open up an SSDT project. That's SQL Server Data Tools. It is the kind of de facto standard way of source controlling a database, Microsoft SQL Server database. I also want to say a shout out to Redgate. They are providing all of the functionality that we're using to hold this conference today. So big thanks, Redgate. I've got my friend of Redgate hoodie on. They have some other tools that do this as well. You have to pay some money for them, but they are really good. So if you're looking to try out a couple of different tools, look at SSDT, look at Redgate, try out some others as well. I used to work at Redgate, so I have a slight preference for those tools, but we can work with whatever you like. In here, I've got all the code for my database. I can build it to check that I've not got any problem, for example, any dependencies or something like that. And I can, so that's going to compile it. It's going to generate what's called a DAC pack for me in the background. If I come down here, you will see, you'll see in the binaries directory, for anybody that understands .NET projects, this should all look fairly familiar. Any moment, we're going to see, it's taken a while to build this one. There we are. It's created this DAC pack for me. That's a bit like a little instruction manual for deploying my database. I can right click and publish that, and that's going to deploy it. And I can choose where I want to deploy it to. Let's, for example, deploy that on my local instance and publish that. That's going to take my source code and deploy it to my local database, so I can have myself a local playground that I can play with. I can also make some changes in here. So, for example, I don't have a foobar table. I'm going to create a foobar table. I can do that inside my project. So I can go into the DBO schema, tables, right click. Let's I'm running out of time, so maybe I won't do that. But I can, at this point, make a change. So let's make a change to a stored procedure, for example, because that's going to be quick and easy because I'm running out of time. I'm just going to add a comment in here. I picked a stored procedure at random, and I'm just going to add a comment, and I can save that. I can commit that back to source control from my Visual Studio. The whole thing is running a lot more slowly now, I think, because I'm sharing my screen, which it means this whole demo is going a lot more slowly than it did beforehand. And I can write a comment, and I can commit that, and I can push that back. So now what you should see, if you're looking at the Git repo in the web browser, as soon as I have pushed this, you should see a couple of things. So first of all, you should see that change has popped up. So if you look for the USP get manager employees stored procedure, you should see my new comment on line 15. Or you can just look at the history. And once that's gone, and you should be able to see that I've made, you should be able to see, once that goes, you should be able to see not only that I've made a change, but also if I go into GitHub, we've also got GitHub Actions up here. I've set up a GitHub action that's going to run the equivalent of that build that I just did in Visual Studio. It's going to do that on some code provided by Microsoft. And everything that I've done today in that demo is using free or community tools. I've not paid a penny for any of this, and you can do the same yourself. You can even clone my repo and do it all for yourself. This is running on some free infrastructure called a build agent that Microsoft is providing for me. It's given me a little VM or a container or something somewhere up in the cloud, and it's running through a bunch of actions. The way that I set this up, if I go to my code, is by I added in this build directory a build.ps1 script, which is the bit that builds the script, but the way that it knows to trigger it is this build.yaml in the .github directory, which is how I define what I want that process to do. I want it to build on a Windows VM. I want it to check out the source code. I want it to add MS build to the path variable, and then I want it to run my build script to build my database. Pretty straightforward, source controlled. And what that's doing is I make a small change. It's then going to validate that it works on infrastructure provided by Microsoft. And as part of that process, I can add testing, and then I can build on that to start doing deployments to dev and test and production environments. And so that's how we begin to automate a bunch of the tasks associated with developing and testing code and releasing it into production. And that's just the beginning of that flow, that focusing on value stream mapping and getting our stuff into production. So to come back to the slides, just to finish off, to summarize everything that I've said in this presentation, Microsoft have taken everything that I've said and dumbed it down into one sentence. DevOps is a union of people, process, and products to enable continuous delivery of value to end users. Yeah, maybe that's the point, but I think that it misses out on a lot of the detail, and it puts a bit too much emphasis on process and product, probably because they sell processes and products and they don't sell people. Fundamentally, I think it does come from people. It's about people doing the right things, having the right priorities, no matter what they tell you, it's a people problem, as you see a lot of the time. As I say, I'll have one comment. This is my one thing that I'd say. People say that DevOps has become a bit of a buzzword and it's become a bit cliche. I think the reason for that is because it works. And the reason I think that is because DevOps provides a shared language that bridges many silos, not just DevOps. This language enables tech folk to collaborate intelligently with senior leadership and budget holders, as well as with other business functions like sales and marketing. DevOps means optimizing for the whole in the broadest sense. So for me, the reason DevOps is effective is it gives a shared language and understanding that both tech people and non-tech people can understand. And it facilitates those conversations. What does it mean for me? I realize I'm over, last two slides. What do you need to do? Relentless focus on value. Think about your end users. What do they actually need? What is the most important work you can do? Then, as Microsoft likes, we'll split it into people, process, and products. People, always be learning. Focus on small autonomous teams with broad skills. Process, collaboration, feedback, visualize the value stream map, understand your constraints. Products, Git, don't bother with any source control system other than Git, it's one. CI, CD tools, infrastructure as code, test frameworks, telemetry, these are the sorts of things you want to be looking at from a technical point of view. And metrics, lead time, deployment frequency, mean time to recovery, and change fail percentage. We are data people. We should be able to get that data. We should be able to visualize it. We should be able to create dashboards with it. We should be ramming those statistics and those metrics down the throats of our IT team, down the throats of our managers, because that is where you improve your processes. I'm going to give the final word of this presentation to Nicole Forsgren. The key to successful change is measuring and understanding the right things with a focus on capabilities, not maturity. She was a person, the primary lead author on accelerate, and she's taught me a lot, and that's the comment I want to finish on. I don't know if we have enough time for questions. I'm aware we've run over. If there's time for questions, great. If not, then never mind. I will be hanging out on Twitter. My Twitter handle is down there, so if you have a question that you don't manage to get answered, I will be monitoring it like a hawk for the next hour. I'm also going to chill out on the SQL Community Slack channel, so you can send me a private message there if you want. My name is Alex Yates on Slack. And I think that's all I have time for. Chill out, folks. Do good things. Stay safe.
Thanks very much, Alex. That was really interesting. A lot of ground covered in a very short time.
I tried.
There's one answer that's come in the questions for the chat, which is that Chernobyl's in Ukraine.
I got it right first time, and then I doubted myself. Thank you.
I did have a question myself, actually, if we've got time for it, which was that I think a lot of people attending this session, I guess, will be developers who potentially don't, particularly in some of these, should we say, less forward-looking organizations, perhaps don't have the sort of influence that you want them to have in a DevOps culture. So if you're not sitting in a DevOps culture already, how do you go about influencing the environment around you, and perhaps it's not something that you have a great deal of control of right now?
It's a very, very difficult question. Let me go back so I can get my subtitles back. How do you influence it? Well, there are a bunch of things you can do. One thing I like to do is literally just put a copy of the Phoenix project on everybody's desk. It's a really easy book to read. It's really easy to learn from it and take actions away from it. If you have a more organization or more business orientated culture, then try Accelerate instead. Learn by, the best thing you can do is pick a small project and try out your whatever you want to do there and demonstrate by success. Measure the right things and say, look, before, when we did it the old way, these were our statistics. These are now our statistics by doing it this way, and do that on something that you have control and autonomy over. Don't try and do that on something where there are so many other people involved. And if that means that it's some local app that you use for development, then that's where you do it. If it's on a particular thing where you have a particular alliance with somebody in a different silo, do that. And the final point is have lunch with people in different silos. One of the biggest things when I come into a company and I see what they're doing, one of the biggest things I pay attention to is where do they eat lunch. If organizations eat lunch at their desk, or they don't eat lunch together, or they don't have any form of social interaction, no wonder they don't know the people that are sitting on the other side of the wall of confusion. No wonder they don't understand their concerns. Because remember, you're a developer, you have a particular role, but you are from one particular silo and you have one particular view of the problem. And it's important to recognize that there are other silos that have problems as well.
Thanks, that helps. Okay, so look, I think we're pretty much out of time, so I'm going to hand over to Ben and let him pick up from here.